Hello PRC people, welcome to Renovators Happy Hour. I'm Christoph Irwin with Positive Energy. We're a building science consulting firm that specializes in building performance in hot, humid climates like yours. I had the great good fortune to work with Logan and Makasia from Solar Spike to support them in their renovation that you're in right now. And we put together a short video highlighting some ideas on moisture control in preservation and renovation projects in hot, humid climates. I hope you enjoy it, and thank you very much.
So we're here today to talk about historic renovations and historic retrofits. And we're going to talk about human factors. The human factors in historic sense are the same as they always are, and the big ones are comfort, health. Usually that's translated as indoor air quality and making sure you're staying healthy by not breathing bad things. Durability and energy performance. Other human factors are budget and skill and the available materials, things like that. So we're going to start with the first two. We're talking about comfort and indoor air quality. So we're standing next to the tool that in the 1920s delivered comfort and indoor air quality. It is the window. It also delivered ergonomics. Note, one finger, a little bit of squeak there. It's on weights. This is the window. So good indoor air quality is because we're allowing fresh outdoor air to come in. The breezes would cool us off. Back in 1920, or I guess it still is today, this is a double hung window, but the upper sash has been painted and caulked shut. So that's comfort and indoor air quality in a historic building. Modern buildings, comfort is a different expectation, right? So specifically, I'm here in Texas, in Austin, Texas. Air conditioning exists and it's brought into all kinds of old buildings, and if not done right can lead to a lot of unintended consequences. So we're going to talk about that next when we talk about durability. All right, so welcome back. We're outside the building now talking about durability. So what we've got to start with when we talk about durability is moisture, right? So just the fact that this old building exists since the 1920s, that is a sign that a quasi-stable moisture equilibrium was reached in this building. And when I say quasi-stable, actually what happens in most old buildings is a gradually declining equilibrium where, this building is 90 years old now and it's got a lot of rot. I'll show you a close-up of this. A lot of moisture has come in, but for the most part, when this building has gotten wet, it has had the ability to get dry. So this is something that when we add mechanical cooling, which we want to do in many locations to achieve modern comfort expectations, when we add mechanical cooling, we create cold surfaces. Cold surfaces are implicitly wet surfaces. There's no way around that. The moisture is always bouncing back and forth on a surface, going from liquid to vapor form. And when I say liquid form, it's not flowing water liquid, it's water that's bound in the material. So it's constantly binding and releasing water, and it can bind more and release less, and that's water accumulating. And eventually it accumulates so high that the surface relative humidity can sustain organisms that eat it and rot it out. So that's what we want to talk about when it comes to durability. Adding mechanical cooling has made all the difference. So essentially when you were thinking about using a historic building in the way a home wants to be used, which is to raise a family, to have your life in, this means you want to be comfortable, you want it to last a long time, and when you add mechanical cooling to an old building, you really need to think carefully about how you do it. So we'll talk about that again when we go around front. Before we jump into the wrap-up, I want to talk to you about exactly where this piece of wood that you just saw the detail of came from. This was the bottom plate that was right above here. So what we had there was groundwater moving by capillarity up into the wood. And just like the hierarchies of control layers, we have bulk water, groundwater and rainwater being controlled, and then air control, vapor control, thermal control. There's also a hierarchy of water in buildings, water moving into and through buildings. First, you're going to have, once again, liquid water, rain and groundwater. Next, you're going to have capillarity. We have water that gets sucked up out of the ground through the pores in that masonry. The next one is going to be air transported moisture through all the numerous air leaks. It's bringing lots of moisture in. And I don't just mean when it's raining, I mean the humidity that comes in, the humid air that comes in. And the last one would be vapor diffusion that can move right through things when it's more humid outside than in. So Water can move into and through building materials in a lot of ways. We need to make sure we're providing for drying potentials. So now we'll talk about human factors, right? So we talked about comfort. This means not just cooling the building in the summer here, but drying the building in the summer here. And this means dedicated dehumidification systems. Side effect cooling, right? That has been our strategy. Excuse me, I said it backwards. Side effect drying has been our strategy ever since air conditioning was invented, meaning, oh, we're going to use an air conditioner to dehumidify the space. Well, let's hope there's enough heat in the space that I run my air conditioner long enough that as a side effect of cooling the space, I dry the space. When we are doing renovations of any sort, and energy performance is one of our goals, this side effect drying of the space is risky, right? Dedicated dehumidification systems, whole house ducted systems, they aren't that expensive. They are worth putting in. So they solve another one of the human factors, health. These dedicated dehumidification systems also have the ventilation function. They bring in MERV 11 or MERV 13 filtered outdoor air, and they introduce it to your space in a very sumptuous way. To not ventilate that way, right, we always hear this, buildings need to breathe. Well, no, people need to breathe, buildings need to stay dry to last a long time. But this idea that we need to have lots of gaps and cracks in our buildings so they last a long time, it might be true for the building if there's no dedicated dehumidification, but for the people, breathing that air that comes in through gaps and cracks, that's a bad idea at best. You've got all kinds of nasty stuff. I mean, pollutants include moisture, when you're talking about it from a building science sense, but particulate matter of all sorts, right? Like dust mite feces, desiccated critter poop, all kinds of nasty stuff is in that air when it comes through, like when it goes through the fissures in that wall and gets into the inside. So that's comfort and health, indoor air quality. Durability, it's all about controlling the moisture. And we talked about the fork in the road, right? You can either do the it is what it is plan, or you can really take care and make sure you've created a building according to good building science principles, which is environmental separation, the 4 control layers, rain, air, vapor, thermal, and then providing for dedicated heating, cooling, and dehumidification on the inside. So just to wrap up this whole thing, what I want you to know is that, what I want you to understand is that when you're thinking about historic preservation work, you really need to think comprehensively. Everything is interlocking, everything affects itself, and to not do that is risky, and that means you're risking your time, your effort, and your money on this. And you could put all those in and not get the result you were wanting. So thank you for listening, and I hope this was helpful.